A transaction schedule is the order of operations such as read or write for multiple transactions. In transaction schedules, after finishing the first transaction, the execution of the second transaction starts. In a transaction schedule, a conflict happens if one operation reads and another one writes the same data. So the order of the read and write affect the outcome. When there are two reads, the outcome is not affected. There are equivalent schedules where the transactions are in order, so they contain the same transactions with every conflicting operations and in the same order, and they always produce the same results. Then there's conflicting schedule where the transactions are out of order. This means that they contain the same transactions with some conflicting operations in different order, and they may produce different results. And a serial schedule is where the transactions are executed one at a time, but they're isolated transactions and there's no concurrency. And there's also a serializable schedule, which is just any schedule that could be made into a serial schedule. The table shown here shows the isolation levels that you can have. So relational databases let DBAs specify these isolation levels for each transaction. And the SQL standard defines these 4 isolation levels. There's the read uncommitted, which is the lowest isolation level. And in this level, one transaction may read not yet committed changes made by other transaction and thereby allowing dirty reads. And in this level, transactions are not isolated from each other. Then there's read committed, and this isolation level guarantees that any data read is committed at the moment that it's read. And so it does not allow for dirty reads. The transaction holds a read or write lock on the current row and prevents other transactions from reading, updating, or deleting it. And then repeated read is the most restrictive isolation level. The transaction holds read locks on all rows it references and write locks on all the rows that it inserts, updates, or deletes. And since other transactions cannot read it, update, or delete those rows, consequently it avoids non-repeatable reads. And finally, serializable is the highest isolation level. A serializable execution is guaranteed to be serializable, and it's defined to be an execution of operations in which concurrently executing transactions appear to be serially executing. Also, schedule types can be non-recoverable, cascading, or strict. A non-recoverable schedule is when no transactions can be rolled back. This may violate the ACID properties since rollback is required for atomic and durable transactions. Cascading schedule is when the rollback of one transaction results in the rollback of another transaction, and this may degrade the database performance. And many databases just don't even allow this. And then there's strict schedule, where the rollback of one transaction does not cause the rollback of other transactions. And this is supported by most databases, and it helps make the recovery system easier, and it improves the efficiency of the database.